Online Architecture Assignment Help. For any assignment-related queries, call us at +1 678 648 4277. You can mail us at info@architectureassignmenthelp.com or reach us at https://www.architectureassignmenthelp.com. Problem point 1. Construct an expression for the bending moment at the root of the lower limbs of a mature maple tree in terms of the girth, length, number of offshoots, etc. Whatever you judge important. How does the bending moment vary as you go up the tree and the limbs and shoots decrease in size and number? Prob 3.7, Text. Problem point 2. Estimate the force Ramelli's laborer, or is it Ramelli himself, must push with in order to just lift a full bucket of water from the well shown in the figure. Prob 3.9, Text. A simply supported beam, indicated by the rollers at the ends, carries a trolley used to lift and transport heavy weights around within the shop. The trolley is motor-powered and can move between the ends of the beam. For some arbitrary location of the trolley along the beam, A.I., what are the reactions at the ends of the beam? 2. Sketch the shear force and bending moment distributions. architectureassignmenthelp.com. 3. How does the maximum bending moment vary with a, i.e., change as the trolley moves from one end to the other? Prob 3.17, Text. Problem point 4. A simply supported beam of length L carries a uniform load per unit length, W0. Over a portion of the length, beta Lx less than Li, determine the reactions at the supports. 2. Draw two free body diagrams, isolating portions of the beam to the right of the origin. Note: include all relevant dimensions as well as known and unknown force and moment components. 3. Apply force equilibrium and find the shear force V as a function of x, plot. 4. Apply moment equilibrium and find how the bending moment MB varies with x, plot. V. Verify that dMB/dx equals V within each region. architectureassignmenthelp.com. Solution point 1. Figure 1.1 shows the sketch of a tree trunk with distributed load W0 as the weight of the trunk plus leaf. In a more realistic form, you can assume that the distributed load is not uniform with the largest load at the root of the trunk and reducing when advancing to the end of the trunk. We get that. This is the moment acting at point A. This moment transfers to the root of the tree, and depending on number of the limbs and offshoots, the moment acting at the root of the tree can be calculated. For a well-grown tree, with evenly distributed numbers of limbs on every side, this resultant moment at the root is general low because of the roughly rotationally symmetric disposition of the limbs around and up the tree. architectureassignmenthelp.com. However, this moment can be large for a tree that has uneven distribution of limbs, example, where there are many limbs on one side but none on the other. This moment can be very large, see Figure 1.2 for illustration. In a subsequent exercise, after we have determined how the local stress within a beam depends upon bending moment, we will model and estimate the bending moment at the root of the limbs as we go up the tree. Solution point 2. Figure 2.1 is a sketch of the FBD and forces that acting on the two gears at the top of the well. There are other forces acting on the system, but we include only those that produce a moment about an axis perpendicular to the paper. Let the weight of the bucket full with water be W, the force that Ramelli exerts at the handle, F Ramelli. We get from moment equilibrium of the large gear. architectureassignmenthelp.com. Now, this force F, its equal and opposite reaction, acts on the smaller gear with radius R, and in turn this gear drives the pulley and retracts the rope to lift up the bucket of water. This force, F, times the radius, R, is equal to the He moment about the vertical shaft, which in the textbook we called MT and was estimated to be MT equals W, RR, RS, /RN, See textbook for definition of all radii appearing in this expression. So F equals mtr, which means that estimating L to be 6 feet, R to be 5 feet, and the radius of the pinion gear, R, at the base of the vertical shaft to be 3/4 foot, we claim that the 16th century source of power must push with a force of 22 pounds, which doesn't sound like an excessive demand until one considers A. How fast he went around, B. How many hours a day he labored. Architecture assignment help.com. Session Point 3. We first isolate the entire beam and determine the reactions. The figure at the left shows an isolation for x less than a, to the left of the point of suspension. Equilibrium gives, taking moments about the cut point, x, CCW positive. Note, the figure shows the sign convention that we used for this class. It is important and recommended that you always state clearly your sign convention when you works on a problem set or an exam in this class to avoid any confusions. Architecture assignment help.com. For x greater than a, we have solving. We can sketch the shear force diagram, SFD, and bending moment diagram, BMD. The dotted line in the BMD of the figure 3.2 shows the plot of the maximum moment as the trolley moves from one end to the other. You can find this plot by observing the equation of maximum MB when the trolley is at any point on the beam. Architecture assignment help.com. The dotted line in the BMD of the figure 3.2 shows the plot of the maximum moment as the trolley moves from one end to the other. You can find this plot by observing the equation of maximum MB when the trolley is at any point on the beam. From this equation, you can see that the MB is in the form of parabolic equation and the maximum moment always occurs where the trolley is located, and it is increasing to the maximum value of rho, L/2, when the trolley is located in the middle of the beam. Architecture assignment help.com. Solution Point 4. Figure 4.1 shows the FBD of the beam. We get that. Architecture assignment help.com. FBD1, cut at the left of the support B, x beta L. Architecture assignment help.com. We plot of SFD and BMD. Also, we can check that our equation is correct by checking whether dmb/dx equals v. Architecture assignment help.com.